Now remember, we're just getting into factor form if possible. We're not doing the zeros, although you could be thinking of what if they did ask for the zeros. What if they did ask for the zeros? Would you know what to do? Number 6 was so easy it might have been hard for somebody. Correct my marker. The way I would learn it, I would do it would be I would get 7x squared. I would get 28. We do 1 and 28, but my outer angle would be gross. We do 28 and 1, but still not get to 45. I could do 4 and 7, that's 49 and 4. Oh, 49 and 4, I like that. The negative 49 and positive 4, but if you don't do guess and check, that's alright. You've also gotten negative 56 and 196. Yeah. And then you should have gotten, hopefully, negative 49 and 4 to get your negative 45. Although if you're doing the star method, you might want to write these down a little bit lower. If you're doing the star method, you still have to put this leading coefficient on top. And then just say, can I reduce? No. So 7x plus 4. X term over constant term. Can I reduce? Yes. 1x minus 7. My guess and check brain would look at this and say, I can do 2b and b to get 2b squared. I can do 1 and 21, 42. 21 and 1, 21 and 2. No? Okay. 3 and 7, 3 and 14. 14 and 3 makes 17. That's good. If you're not that kind of person, that's okay. You would have said through modified x at some point to get your 42 and your 17. Maybe you would have figured out that you could do 14 and 3. At which point we could write that leading coefficient of 2. No reducing, so 2x plus 3. Oh, careful, 2b plus 3. That's 1. And then that one can reduce to be a 1 and a 7, so 1x plus 7. Oh, it's a b. Don't worry, if you don't know my methods, I was seeing what you could do on your own. I have 3 different methods up here on the board, and all of them are great. The point is that not that you think like me, not that you factor like me, but that you have a way that works for you. Do you have a question, Sophia?
On the test, like, is this going to be
Factor?
Yeah.
I'll be a part of it. I'll probably say something like zeros. But
what if I keep using the wrong variable?
Oh, no, it's important to have the right variable. That's why I was like, oh, I mean B. It's important to have the right variable.
Oh, this is X. Wait, why does it matter?
Because depending on the context of like future problems, you could have X being one thing and B being another and N being another, so you could see them get all mixed up. This one, just in case you guys are curious on guess and check, there's just a few of you that I think might want to do it if you don't already. It's kind of nice. It's neat. There's like all this extra scratch work. But you do have to be able to think through mental math, like adding and subtracting as you're forming. I'm thinking of how to make negative 18, 1 and 18, but then that would be 18 times 5. 18 and 1, but still 5 and 18. So then I think maybe 2 and 9, 45 and 2, no, 10 and 9. Oh, 10 and 9, 2 times 5. Want the 10 to be a negative and the 9 to be a positive. Once again, you don't have to do it that way. Could have done 5 times negative 18 in some way, shape, or form. Could have figured out that negative 10 and 9, make that negative 1. You could go to grouping, you could go to the box. You could also do the star, like that 5 above. Ask yourself, can it reduce? No. So 5 what? B. 5b plus 9. And then can that reduce? Yes. 1b minus 2. Silly, but it works.
I like that.
And now, out there that you guys are using that I don't expect. I expect grouping because Mr. Che does grouping. I expect the star partially because we use the modified X. This just adds one little extra step. So some of you might have seen it yesterday and been like, yes, please. So maybe you're trying to do that one. And then maybe if you learned factoring at a different school, you might have done the box method. So let's have it up here. Grouping method. For actually all of them. Do you see how all of them, I still want to get my GCF out first, right? So in number 10, I look at all those terms and I say, there's a shared 4, there's a shared n squared. Pull that out. And what's super important for all of these is that you don't forget about him. When you pull out the GCF, he needs to be in the answers. You're going to kind of ignore him, forget about him. I haven't written that answer down yet. I wanted to explain it first. But that 4n squared, he pulls out just to make everything easier, but it's really easy to forget him. Please don't. So we're looking at what's left. The 7n squared plus 4n minus 20. If you were doing it the Mr. Che way, which is perfect, I have some pre-calc kids, we spent like a whole day on factoring. They're like, we're going to do the grouping. I'm like, that's fine. I don't mind. As long as you do it correctly. I don't mind. Grouping would say multiply a times c, the modified x method. You have your b, you find your guys that multiply to be the top and add to be the bottom. Right? I went ahead and wrote the whole thing because I know myself and I know that I forget about this guy way too easily. So I wrote the whole thing so I wouldn't forget about him. But we're really looking at the inside. In grouping, you take this first initial term and you use these guys to split him up into where he came from. 4n came from a positive 14n and a negative 10n. You don't show all this stuff. But technically, you have like n squared and you have like n's. In the sense of this times this is an n squared and this plus this is an n. So technically, even though we don't write it because it's a shortcut, the 4n came from a negative 10n and a 14n. And then we look at each of these. Now, some of you might put parentheses. It's dangerous once you have negatives. I like just kind of doing a little brace and saying, who's in common? Pull them out. Who's in common? A negative 10. Pull them out. It's safer for me. And then I look at the whole picture of what's left and say, who's in common? Well, this n plus 2 is, so I pull him out. The 4n squared is still there. N plus 2 comes, and then the 7n minus 10 is left. This would be the grouping. J.
What number is that? It's kind of hard. Is it 18?
Oh, this guy?
No. Up. There's an arrow pointing to him. Up. Right above that. Right
Oh, it's a 10. Sorry.
That's a 10?
Yeah. 14 and 10. It's stealing from over here.
Okay.
Yeah, you're right. It does look weird. There we go. Okay. That's grouping. That's Mr. Che's way. The star method, basically, I mean, check it, guys. The star method does the same thing in that the GCF is first. We can't forget about the 4n squared. He has to be in the answer. But I do the modified x. But it's a star because, well, we do the modified x with the negative 140, the 4, the negative 10, and the 14. But I write them down and I draw a line to make a star. Above that line, I always choose the leading coefficient. I always choose A. So A times C, B, and then I have A just waiting. And I always ask myself the question, can I reduce? If I can, I must to get my right factors. But if you do the star correctly, with the leading coefficient on top, these will always be your variable terms. These will always be your constants, and they come in pairs. So the 1 was the coefficient to the variable, which in this one is an n, so I know it's weird, but it's 1n plus 2. Those go together, 1n plus 2. And this goes together, 7n minus 10. It's just neater because it's less work. Still doing the same process. But then the box is super interesting. Is anybody doing the box?
How do you do the box?
Doing it. Anybody else? No. Okay. The box. Do you guys see how I filled in? Where'd he come from?
Just the first one.
Yeah. Now I still need to remember my 4n squared. Like he's going to be a part of my answer. So I guess I should write him and just not forget him. That's the hard part with the star or the box. If you're not writing the whole thing, oh man, it's easy to forget that guy. Okay. But the 7n squared, yeah, came from the first term. So I filled him in, and then I filled in the negative 20 from the last term, right? Then I came off to the side and did my negative 140, so it's similar to the star, except when I do my negative 10 and my 14, I make that an n, and I make that an n. It can be in either box, it doesn't matter, but I make them n's. And here's how the box method works. You go every row and every column factoring out what's in common. So what's in common, if you're looking at negative 10n and negative 20 and negative 10. What's in common if you look at a negative 20 and a 14n? I think just a 2, right? What's in common between a 7n squared and a negative 10n?
No.
An n. See it?
Wouldn't that be n? 2n? What's negative 10n?
Oh, but I haven't gone diagonal. So this way, there's a negative 10, but no n because he doesn't have it.
Okay.
This way, no n, so just the 2. See it? This
Oh,
way.
so you're doing all directions?
Yeah. So I factored out this way. What's in common? Factored out this way, just with these two terms. What's in common?
Okay.
Factored out that way. What's in common? Now, what's in common this way? 7n. This is grouping simplified. Because you're taking your modified x method, basically, you're putting your negative. So we could even, for you guys who know the modified x, we can use the modified x in everybody. Because we would use our negative 140. We would use our 4. We would get our negative 10 and our 14. We would just take them and we would make these out of them. But it's basically a way of nicely organizing it. It's like, who's in common? Who's in common? What's in common? What's in common? Ha ha! So then you would go ahead and write your 7n. 7n minus 10. And n plus 2. Long story short, there are many ways to factor.
It's actually pretty easy, I like that.
I like the box. Yeah, there are many different ways to work.
I always choose the greatest one, so like, if the 14 and 20, if 4 could go into it, you wouldn't choose a 2, you would choose a 4.
Take out the GCF. Yeah. Good. Take out the biggest one. Kind of like when we're reducing in this guy, we reduce it as much as possible, so we pull out as much as possible. Then it's a 1. So, regular pre-cal today, because you guys were doing the worksheet, you were doing that extra work, they were kind of just factoring. I had some other kids make problems, that some of them were possible problems, that didn't help. But Kenya was making some really good ones. And they were trying to make hard ones, give them to each other, and then factor them. I had to make an easy one and then a hard one. Oh, I don't even remember what the one was that she did. Here, let me freeze the screen real fast. Let me go get that one, just because it was a good one with crazy hard numbers. And I want you guys to just choose a method to factor. Just prove to yourselves and to me that you can. Does that make sense? Let me go find that crazy one. She was working hard trying to make the numbers kind of high up there. Let's see. I think I have it saved in their notes. Oh, I only saved one of them? Oh, so sad. That wasn't even the hardest one. Okay, that's okay. It works, though. It works. It gives us an example. All right. So what if I was to give you separate group chat? What are we talking about? I'll make one real fast.
Your phone is going through my texts.
Oh my goodness. Wow, you're so original.
Jaden, wake up.
Okay, make sure it's good, but then I got it. You ready? Let me not write it on the whiteboard. Okay. 12x squared minus 56x minus 55.
Sorry, I don't like things.
Go for a method.
Box.
thought I said box it. I thought you meant like just box it and be done like that. Never mind.
Alec.
Yes. Alex. Why
I
are
was
you going
concerned.
Alex? I'm sorry. Box method is totally viable. I actually enjoy that one, but the star is a little bit faster. Well, I guess in check. I don't do anything. Alright, you said 12 times 55.
-616.
Okay, there you go. Everybody has negative 616.
Yeah, but what are the two factors?
16. Sorry, negative 616.
Oh.
616. That's very close.
Okay, shh. Let people focus. There are 2 people that are done. KJ and Jaden, can you check your answers real fast? I'll go over to KJ and see if you guys agree or not. Because I'm going to use you guys for helping me out. Keep you guys at the same time, please. Okay, if so, can you guys go together to and hop in not the first floor but the second floor? And then when you finish and pull out the glass, we'll just kind of both pieces of the It's a that. It's a that. You guys talk about like these no driving.
Yeah.
Where Jaden was like, what? What? Which way are we doing?
Oh, yeah, you're right.
The one that was like an orange.
Orange? We're doing the star?
Star, yes.
But I thought people do the box. Let me do both. So the star would have been negative 616, trying to get negative 56. What did you guys get as your pairs? Okay. What would be different in the box? So we would have just stolen that. We would have stolen that. And then we would have basically done that. But we would have just chosen the negative 66 and made him an X term. And the 10 made him an X term. Over here, we would have drawn a line on top after doing that work. We would have brought down the leading coefficient of 12, asking ourselves the question, can we reduce? We can reduce by 2, and that would be 6 and 5. And this one we can reduce by 6 and get 2 and 11. If you don't reduce fully, you won't get all the way there. Because, actually, this was your question. Over here, we're supposed to pull out as much or as high as we can. So we have to reduce fully or pull out as much as we can. Over here, I see us able to pull out a 5 that direction. I see us able to pull out a 6x that direction. I see us able to pull out a 2x that direction and a -11 that direction. Look at them both. Do they agree? Either way, you should end up with the 2x minus 11 times a 6x plus. The hardest part, if you get the method down or a method down, is probably still figuring out these guys. Breaking down. Because if you put it the other way, it's just going to be the switch of the
Oh.
How are we doing? Do we have a way?
I actually did it right.
Good though. Like, we just want a way. I want a way. I want a way that works with you, that you don't have to look back and be like, I can do this thing called factoring.
Is it? Is this it?
As long as yes.
Oh.
It's not from her. It's from my small group tonight. I'm in charge of making the meats for the pulled pork sandwich. And sadly, I live too far away, and I leave too early. To like turn it on in the morning and let it keep going. So it was in the fridge until I kind of just calculated and like, oh, I need to get it started. Thanks, guys. But you guys don't have to suffer the really good smells because it's not like that. Okay. Let's go. Right now. We need to go through section 2.2.
We're confused.
Right? You guys are supposed to. No, you got it. You got the
We're
last
like, we're like
You
this
would?
early
It's
in.
my toe. It's okay, it's right there. I figured you could stand it. Alright, polynomials up, higher orders. Come on. We do homework. It's supposed to be due tomorrow.
That's not gonna.
I don't think it's gonna happen. Does that make sense?
Yeah.
So I'm changing the deadline, and so that's why.
I have so much.
I think a picture right here will cost like a good boy.
I know, me too.
Because we were supposed to have notes copied for today so you could just fill in, right? That was the idea.
I do not.
But even then, I only had to do some of them. So, okay, this is why we don't get stuff done. Okay. Polynomials. Here are some things about polynomials because, long story short, at the end of section 2.2, I'm going to give you a nasty polynomial and say, tell me all about them and graph them without a calculator. So, hence the dilemma, right? If you don't have a calculator, what are you supposed to do? Well, maybe look for x-intercepts. Maybe look for y-intercepts. Maybe, oh wait, to look for x-intercepts, don't you have to factor a trinomial or a higher degree polynomial? So we need to figure out how to factor these harder guys. We have to figure out how to, find the zeros of them by factoring, how to find the y-intercepts by just plugging in x equals 0. How to know in our minds roughly kind of what it looks like. Because if I ask you to graph a quadratic, don't you kind of have in your mind a U or a upside down U, right? You have a parabola or a downward spacing parabola. You have an idea, but what about a cubic or a quartic or a quintic or a, oh no. So the very first thing I want you to know about any graph of a polynomial, working up to those really big Mala Bahama ones at the end of the section, yes, I know, shout out to Mrs. Leon, is, oh, I don't call them those anymore. That's all for her. All polynomials will always be continuous, aka no jumps, no breaks, no holds, no vertical asymptotes. It's never going to look like this. I don't have to worry about something crazy happening because all polynomials are smooth curves. No asymptotes of polynomials. They're coming later on. As soon as you have a denominator, then there's the possibility. So the goal is to be able to graph crazy higher degree polynomials by hand. Higher order, higher degree. Okay. So a few things that you guys know. First of all, always continuous, and second of all, always smooth terms. Now, there are other graphs that might be broken, but not these guys, and there are other graphs that might have sharp turns, but not these ones. Because in section 2.1, didn't we write down the general form of any polynomial with a whole like a x to the n, and then we had like a something else with like a b x to the n minus 1, and then we had a polynomial is an addition or subtraction of terms with x raised to whole powers. So no negative exponents and no fractional. No radicals, no denominators. Okay, with that, I'm dual paging it. Because, I mean, that's great. Okay, it's going to be smooth, whatever it is, and it's not going to be broken, whatever it is, but how does that help? Well, let's go a step further. What if we're talking about the degree itself? The degree itself. So n is the degree, quick reminder from the beginning of chapter 2. If n is even, if it's 2, if it's 4, if it's 6, if it's 8, if the degree of the polynomial is an even degree, the degree of a polynomial is an even degree. Well, hold on. This guy isn't even transformed. This is actually like parent function, right? So if I'm talking about x to the 4th or x to the 6th or x to the 8th, I'm just talking about their parent functions. Without me going too crazy, basically x squared would be this dude. If I could actually get him on 0, 0. If I was to have more time and I was to have you guys get out your graphing calculators, pre-cal will probably do this, and have them graph x squared, have them graph x to the 4th. Have them graph x to the 6th. All you're going to see is them getting steeper and steeper. Why would they be getting steeper and steeper?
Because
the degree is getting higher. Yeah. If I was to plug, for instance, 2 into x squared, okay, 2 squared is 4. But if I was to plug 2 into x cubed, 2 cubed is 8. 2, wait, we're not even doing cube, we're doing even powers. That'd be 2 squared is 4, 2 to the 4th is 16. 2 to the 6th would be 64, which would be way up higher, right? Like it goes way up. So these are getting steeper and steeper, but what do you notice that's similar amongst all of these guys? They're all kind of parabolic, yeah. They're all parabolic, they're all like parabolas, they're all like the x squared. Al, you have those pictures?
Yes, I do.
But what if n is odd? Well, the most basic odd, isn't that x cubed? And x cubed, well, if I plug in 2, I get 8, right? If I was to have you plug in, instead of x cubed, x to the 5th, another odd degree, guess what's going to happen? Oops, if I can make them. It's going to be steeper. If I have you plug in x to the 7th, guess what's going to happen? Just steeper. If I have you plug in x to the 9th. Now, eventually, this one gets hard because it starts looking like a line because it's getting thinner and thinner and thinner. It's still a cubic, well, it's still an odd degree polynomial. It's just going to look weirder because it's being stretched so much. But the reason it's being stretched is 2 cubed is 8, but 2 to the 5th power, well, on sync, that's going to be something more like 40? Could be 8 times 4, right? 2 to the 7th power, that'd be 160. To the 9th power. Anyway, it's just going to go higher and higher and higher. But what do you notice that's the same with all the odd ones? Yeah, it's not like a special name. We should probably make one up, right? That'd be nicer. We have the parabola and the swoopy doop. I like for e to the x. That's the hard part.
Oh, yeah.
Like this.
Yeah.
Exponential growth. Think if you think of a good name to make creative ones.
Squiggle.
The squiggle.
Mr. Squiggle.
Mr.
Is the swerve one? It's like that, right? No, that would be like the swerve one.
So, Mr.
Or like a
Squiggle.
ducky. Oh, I get it.
Mr.
I get
Squiggle.
it. It's the swerve. We can call it the swerve. You're
Squiggle.
like going and all of a sudden you have to like swerve over, getting over the skirt. Anyway, stop. Okay. This leads us to the leading coefficient test. Leading coefficient, leading. If he's leading, isn't he like of the highest degree term?
Yes.
Right? Because if he's leading, if they're written, you should write polynomials in descending order, unless it's something awkward like negative x squared plus 4. Then we might write it like a 4 minus x squared just because it's easier to see. Like the other way is gross. It's not wrong, but this one would be a little bit more like preferred. But usually we do descending order. The highest guy, the highest degree is up at left, and then we just count down from there. So leading coefficient test, we're talking about the coefficient of the highest degree term. There might be more. But we have this whole if n is even and if n is odd because that determines what our graph basically looks like. So if a is greater than 0, this is also called the n behavior test. I'm going to talk about n behavior a lot. whatever is going on the inside. Well, let's put it this way. If I have any sort of polynomial that has an even degree that's parabolic, I'm going to have, if A is positive, I'm going to have the ends pointed up. If A is positive, I'm going to have the ends pointed down if it's negative. Now, right now, I don't have any extra terms technically being added, so I can actually just be like, oh, what's the problem at 0, 0? Yep, it's going up, or yep, it's going down. And if A is, oh, I'm sorry. Do you see how I totally organized that wrong? This guy should be up here. The even, either A is positive or A is negative. That's my bad, I'm sorry. Even, either up or down. Odd, I either have going from negative infinity to positive infinity, or coming from positive infinity to negative infinity. Now, this is snazzy and all, this whole like circling thing. But there's snazzy notation that actually allows us to talk about what's going on to the left and to the right. To the left and to the right for nastier polynomials too. Because guys, check it. These ones, they're not just simple parabolas, or they're not just simple swerves, right? They're not just simple parabolas and simple swerves. Meaning there's plus or minuses of like all these extra terms, and it's making it do all this crazy smooth stuff, but still stuff in between the ends. But if you notice, even if you can't read the little baby letters, can you tell whether this guy is odd or even?
Yes.
Yeah, because look, aren't they going opposite directions? Opposite directions, he's odd, right? Can you tell whether the coefficient is a positive coefficient or a negative leading coefficient?
Yes.
Yeah. Which one would it have to be?
That goes up to the right.
So even without reading the words, I know that this one, n is odd and A is positive, right? And this one, I know n is odd and A is negative because it's the opposite direction. But let me zoom in so it's not just like, hey, what's going on to the left? Well, I don't know. Let me just show a little arrow and yay. And there's math to describe this whole it going up thing. And we use this thing called an arrow. Well, wait a minute. You just told me not to use an arrow. No. Use an arrow, but in a proper way. Use an arrow, but in a proper way. So, let's see. How can I put this in words to help out? This would be increasing to the right. If we're trying to state mathematically that a function is increasing to the right, we could say, oh, this is nasty. It's hard to read. Let me turn off the light. Increasing. What are the y's doing? Going up. See it? After x approaches positive infinity. Increasing. Y's are going up to the right. X is going to positive infinity also. As x goes to the right, y goes up. Both of them going to positive infinity. But down here, I'm talking about decreasing. You guys don't have to worry about the big old paragraphs if you don't want to. That's okay. Decreasing to the left. So they ask us the end behavior. Yes, it's important to be able to know, like in a graph, what it would be doing. But it's also important to start using some of this notation. Because decreasing means the y's are going down, 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 without bound. That's going to negative infinity. And x is going to negative infinity also if I'm going to the left. But something that we need to write down in our notes is that this little arrow in math means approaches. So you can go to a calculus kid, ask to see their limits homework. And anytime there's an arrow, be like, approaches! And they're like, yeah. It's a really important word. We can't really do much else right now, but for chapter 12. But this arrow, we're going to see it off and on throughout the year. Approaches. So I know on the graph you guys can see this one is increasing to the left, but does the math make sense? Increasing means the y's need to go to positive infinity, but to the left means x needs to go to negative infinity. As x goes to the left, y's go up. That's what this notation is doing. Or decreasing to the right. Y's are going down now to negative infinity as x's are going up to positive infinity. It's just a snazzy way of writing it. But guys, this page, we technically were only talking about odd degree functions, right? So I think I have other pictures on the other page, and they're going to be great to look at. But I'm more just curious. You don't have to keep on writing the words if you're getting the idea. Can't I kind of just say? If I'm talking about a graph increasing, if I'm talking about the graph decreasing, if I'm trying to explain that it's to the right, which would also be the right end behavior, that's another way of saying it, or to the left. There are things that you're just going to use for these phrases. And that'd be the left end behavior. Increasing, we're talking about the y's. Decreasing, we're talking about the y's. But if I'm increasing, the y's are going up, 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 and away. Decreasing, going down, 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 and below. To the right and to the left, I'm talking about my horizontal measurements, right? To the right, x is getting bigger, going more positive, and to the left, x is not getting smaller per se, it's more just going negative. Bigger and bigger and bigger negatives, actually. So I don't think you guys have to write all of this stuff for the even ones. It's more just, when you think about how you would describe the even ones. Just do the two sketches, because the two sketches are great. They remind you it could be just a simple parabola-ish thing, even if n is 6 or 8 or 10. But it could have some weird swoopy swoops in between, some weird swerves and smooth curves. Don't worry about, per se, the paragraphs. Get a quick sketch. And can you describe to me what's going on to the right and to the left? Even without maybe being able to see it up here. As x goes to positive infinity, what's f of x doing? As x goes to negative infinity, what's f of x doing? Understand that means as I go to the right, my function is, or as I go to the left, my function is. Read it and state your thoughts in a very mathematical way. So these ones, when I go to the right, aren't these both going up? To the right and the left, aren't these both going down? We've done a lot. We've done a lot of good stuff. The problem is we have more to do. This homework won't be due till Monday, but you guys can definitely start way more than pre-calc can. Bye guys. Later, Gators.